Okay, so to help travelers know what to expect, researchers collected the prices of commodities in 16 cities throughout the world. Here are box plots comparing the prices of a ride on public transportation, a newspaper, and a cup of coffee in 16 cities. All prices are in US dollars. So, I've given you these little box plots here. What do you notice about each of the box plots?
They have outliers.
They all have an outlier. So, on average, which commodity is the most expensive?
Coffee.
Yep, because the bulk of its Q3 minus Q1 values are higher than everything else, so it's going to be coffee. Is a newspaper always more expensive than a ride on public transportation?
No.
Why?
Because its minimum value is.
It's like almost one.
Well, does it count with the fences? Like if it's.
That's just your min and max. We don't have fences on here.
Oh, that is okay.
Yeah. So you're right. Obviously, it's not necessarily it's not necessarily more expensive. The tails or the tail of each overlaps some. Does the presence of outliers affect your conclusions in A or B?
No.
No, we didn't change anything because of that, so nope. All right. Campsites. Shown below are the histogram and the summary statistics for the number of campsites at public parks in Vermont. So obviously I've kind of had to smush it in there a little bit. And I did my best to copy over the little histogram as, good as I could. We have number of parks on the left. The number of sites per park is on the bottom. So which statistic would you use to identify the center and spread of the distribution and why? So basically, are we using mean and standard deviation or median and IQR?
Is median and IQR the one that goes with bimodal?
Yes.
Would that graph be like considered bimodal? Or
I wouldn't consider it bimodal,
it's like skewed?
but it's very skewed, right? So I would say median and IQR, which you would have had that part right, but and because it's skewed.
And if it's like mean and standard deviation, is that like when it's uniform?
Unimodal and symmetric.
Okay.
The big part is the symmetric portion. Yeah. Because uniform could kind of go either way. Not exactly. Uniform is typically going to be classified in symmetric, more or less. How many parks would you classify as outliers? We should do the math. With our outlier calculation formula that you have. So.
Oh wait, is that like the minus one, like the
Q1, 28.
Yeah.
Minus 1.5 times IQR. IQR is Q3 minus Q1, which is 50. And then the other one is Q3, which is 78, plus 1.5 times 50,
Wait, why are you using 50? Is that just because it's the...
Q3 minus Q1 is 50.
Oh, okay.
For the first one, I got negative 47.
Okay, so nothing is an outlier on that end.
I had to redo it because I'm like, wait, I had to do it.
Sometimes that's the case, and you have to be like, okay, that doesn't make sense for this particular
Yeah.
situation. You can't have negative sites.
And then I got 153.
So based on that, how many parks would you classify as outliers?
3?
3 for sure. Possibly a 4th one. We don't exactly know what these numbers are because of the scaling that was given to us. So definitely 3, possibly 4. But if you just said 3, I would give that to you because we don't know what the increments are that are on there, so. Create a box plot for these data. So I'm gonna draw a little line here. Number of sites per park. And I'm going from 0 to 300 increments of 50. And that's just because that's what they had up there on my histogram. So I'm just using the same increments. All right, so our minimum is 0. So I put a line at 0. That's going to be coming off my first little whisker. My Q1 is 28. Connect that like that. Median is 43.5. Q3 is 78. So I now have made my little box. Now, my max is 275. Okay, so I'm not drawing that as my final line though, because I know that anything past 153 is an outlier. In this case, they did not give me a list of numbers, right? All I have is my summary statistics and a histogram. So I'm going to use my upper fence, okay, to determine this. Now, if my upper fence was, I'm just going to say it this way, was 153 like it is, and there wasn't a number right here, I'm going to say this isn't an outlier for the purpose of this. Just know that, like, if you classify it as an outlier, like, I'm not going to take off for it because it's so close, but, like, I'm not going to for the purpose of this. But let's say that this point here just didn't exist at all. Then somewhere between 100 and 150, around the 125 mark, I would be putting my final line because that shows me that's where that value is, right? And then I'm going to be using those other 3 as my outlier numbers. But since I have one that's so close right there to what I think that fence is, I'm just going to use the fence number as my upper value.
If we did have the thing of numbers, that's like when you choose the highest number, it's not past the...
Yes. Yep. Which is why I was saying, like, if this one was gone, I would be choosing, like, 125-ish. And obviously it's an approximation, but that would be my max then because everything to the right of my pen right now would be an outlier that I know of for sure. But since I have this one here, it could go either way because I don't know exactly what the value is. I'm just going to say for the purpose of this that it's not one, and I'm just going to make that my upper fence. And if you were just like, well, I feel like it's an outlier, then you can always do your fence and then put, you know, that little thing right there. But I would say I'm just not going to classify it as an outlier for right now, and I'm just going to classify those other 3 things as outliers. So it looked like I'm at about, I don't know, 180. I have a little outlier. 200-ish, I have an outlier. And 275 was my max, so I kind of know a little better where that one is. So I've got my 3 outliers and my box plot. Notice that my box plot still, even without the outliers, still shows a skew, right? Still skewed right. So just notice that. As far as a concluding thing based on what I've been given, I would say something along the lines of the data is skewed right. There are three or four outliers. Since everything else was like given to you directly and you didn't have to find it, I wouldn't say anything else really about this one. When you're finding your 5-number summary, that's when I usually go in and I write a conclusion that deals with the 5-number summary. So, but I would say that's sufficient for this problem considering everything was given to you. Aside from what we just wrote, they didn't really tell us that information. All right. So, a National Vital Statistics report indicated that nearly 300,000 Black Americans died in 2003, compared with just over 2 million white Americans. I thought I read that wrong. Here are histograms displaying the distributions of their ages at death. So describe the overall shape of these distributions. What do we see? Yep, unimodal, skewed left. How do these distributions differ?
Are we talking just like how the graph looks or how like the numbers?
Like, what do you notice about like the numbers and stuff like that? Like as far as like the quantity of people that died based on ages and things like that.
They're measuring up to 30 on the white and 25 for the black.
Well, I mean more so about the actual data that's there, not that. That's just a scaling thing.
And the bottom is the ages, right?
Yes.
Okay. I guess like more white people were living to be like a lot older.
Yeah. What else do you notice?
I
What
don't
do you
know.
notice like about like the death
There's,
rate?
It like gets like it's more. I don't know how to describe it. Like there's a big jump on the white, like between 74 and 75, like that range.
Yep. After 74 years old, a lot more white Americans are dying versus with the Black Americans, it seems that there's like a lot more compared to the white that have died from ages like I would say 25-ish on up really to 74, and then there's kind of a jump for white Americans to die more often. So something like from 25 to 74. Come on. More Black Americans died versus 75 plus more white Americans died. And some of that I'm seeing obviously from looking at, you pointed out that one of the scales is only going to 25, the other one is going up to 30. That's because obviously I have some over 25 percent on the white American one, and then for black Americans I don't have anything over 25%, and so that's part of why the scaling is that way. But just make sure that you notice, and I tried to still kind of line stuff up the same even though I wasn't going up as high, because something can look drastically different if you don't notice that the scaling's different. Sometimes they'll even get you so that the age gaps are different, so just make sure you look at all the scaling things. Even though that wasn't exactly what I was asking, it was good that you pointed that out as well, because that can make a huge difference when you're reading data and stuff like that. Now, you're probably thinking, like you kind of pointed it out a minute ago, you were like, the bottom is ages, right? So what is the problem with these bar graphs that I have given you? Like, where did they have an issue? Yeah, there's no labels other than the percentages, right? And these are just copied out of the book. This was a part of the question in the book. I didn't intentionally leave it off or something. There's no labels. What else? I just spelled labels wrong.
Should the ages be on the other side or something? It does not matter.
Or should like the scale be the same up with graphs, like the numbers on the side, or no?
I mean, they could be, but that would just be adding a 30 to the side that doesn't really need it because nothing's going up that high. What do you notice about the ages?
They're not like spread out uniform. Like it goes like 0 to 4 and then 5 to 14. Like,
Yeah.
Not even.
All the gaps should be the same. And then 85 plus, I mean, that could be somebody up to 110. Like, you don't know. So, no labels. The span of years is not constant. Because we have something like 0 to 4, then I've got 5 to 14, and then I've got 85 plus.
Is that gonna happen a lot? Like, will they give us just like faulty graphs and we have to like determine? whether
I
it's
mean,
like-
sometimes. But they can only ask you but so much based on the faulty graph if they don't give you enough information. So it would be something like this. But yes, it's possible. Some of them are trick questions sometimes to get you to be like, I can't do this because blah, blah, blah. So,
Will they always like outright tell you like that, or will they?
not necessarily.
Okay.
There's one question that's in a later chapter that is like all out a trick question, trying to get you to say that it's like the wrong type of data. Like, that's literally all it wants you to say is like it's supposed to be something that's quantitative data and they gave you categorical or vice versa, and you have to be like, this was categorical data, I can't do this. Like, this only applies like whatever they're asking you to
I'm
do.
like looking out for it every time. I'm trying to think.
It's like a lot later. Like, it's probably something we won't do till after Christmas.
Is the stats exam online or is it?
Yes, but the short answer part's not.
Is it
It's
short
like a
answer
half
by,
and
like,
half.
making graphs or something?
Well, like the short answer part is like there's like 6 questions that you have to answer, like write out everything by hand, versus like the other stuff's multiple choice. And the multiple choice you have to like, you'll still have like scrap paper, but then you have to like submit the answer online.
Is it kind of like free response, like the short answer?
Mhm. I just always say short answer, but it's literally, yeah, they call it free response.
Okay.
Just like the pre-cal one was. It's just the multiple choice part's online now. All right. Gas prices. Here are box plots of weekly gas prices at a service station in the Midwestern United States. Prices in dollars per gallon. Compare the distribution of prices over the 3 years.
Got more expensive this time.
Yep. Average price is increasing. What else?
You got like the prices vary more, I guess. Like there's a wider range.
Yeah. There's a more of a variation in prices. What else do we notice?
I don't know if it like applies to this question, but there's outliers.
Yep. So we have 3 outliers in 2002
Oh. I
and
see.
1 in 2004. Now, it's going to be really hard for you to probably see this, especially for the one. So, if I've given you a graph, there's some benefit for you to go and look in the book and see what the graph really looks like, because obviously I can't do it perfectly, and I think but what do you notice about the graphs if I turn them this way? The one for 2002, you're not going to recognize what I'm trying to get you to say most likely, but 2003, 2004, what do you notice?
Progressively more skewed, right?
Yeah. 2003 and 2004 are skewed right. 2003 obviously is only really slightly skewed, but 2002 is skewed left primarily because of all the outliers. So that's why I was like, you may or may not recognize that. So 2002 skewed left. 2003 and 2004 skewed right. Then part B, in which year were the prices least stable? I think you kind of had already said this.
2004.
Yeah, 2004, there's the widest range there. The other years, like 2002 is probably the most stable because everything's kind of packed in. Outside of those 3 outliers, like, it's pretty packed in, but 2004 is very spread out, so 2004, the range was range was wider in regards to price. And it has the largest IQR, which again, my graph's not perfect, so it's kind of hard to see that, but the IQR is bigger in 2004 than any other one. And also know if I give you a graph, like, on a quiz or a test or something, like, there may be things that I'm, like, trying to get you to say, but my graphs, if it's, like, not, like, perfect, that I'm gonna have to, like, adjust some answers a little bit or, like, be more flexible on answers if it's not super clear. Like, if you didn't tell me that 2002 was skewed left, like, I would not have taken off for that, right? Because it's kind of hard to tell if you didn't know I was doing it based off the fact that there was, like, multiple outliers. So, or you can say something like, it's skewed left with the outliers, but if I remove the outliers, it's not skewed or something like that. Like, that would also be another way you could write it. Okay, it's like we're at the end of this page, right? All right. A survey of 1,021 school-age children was conducted by randomly selecting children from several large urban elementary schools. 2 of the questions concerned eye color and hair color. In the survey, the following codes were used. So they used one for, y'all can read it. I'm not going to read all that down. The statistics students analyzing the data were asked to study the relationship between eye and hair color. They produced this plot. So you've got eye color on the left and hair color on the bottom, and notice there's a couple like outliers like listed off there or whatever. Also don't know why like the median value is not drawn in on all of those. Just assume it's halfway between on each of them because I don't know why it's not listed there.
On ours, we have different colors. They're
Different
like pink and blue.
That's because I think I printed it up here the other day because I didn't have time to run to the other building.
It doesn't have it.
And the toner is weird in this one for some reason. Yeah, I didn't have time to escape to the other building, so I was like, oh no, I have to print it right here. So it doesn't always print them the exact same. So, is this graph appropriate? If so, summarize the findings. If not, explain why not.
I'm still a little confused on the graph part, like the 1 equals blonde, 1 equals. I'm just confused. Like,
They're just assigning a number to everything.
But how does it like associate with each other on the graph?
Well, I think what they're trying to say is like hair color, like then it's based on like whatever your eye color was. It's like how they like scale this.
It's kind of a weird graph.
I feel like it doesn't work, maybe.
Why? I'm gonna say why regardless. So
Okay. It just looks wrong. That's my answer.
it just
Doesn't,
looks
it
wrong.
doesn't seem right.
It feels like it would have been better to use like a bar graph or something. Or bar chart or whatever.
Josh, you want to throw any input in on this question?
Well, I wasn't really listening, but I'm guessing it's because it's categorical.
Is that what
Is
we were
that
just
right?
talking about?
Yes. I really didn't think it was in this section. I'm not even gonna lie. I really thought it was like later in the year. I wasn't like trying to say that to throw y'all off. I did not remember it was this early in the section.
I know, I was saying like, I'm gonna look out for that.
I missed it on the like next question.
That's embarrassing.
So is this graph appropriate? No, both are categorical variables.
Okay.
So y'all were like, this graph just doesn't make sense. And I'm
I
like,
know.
I know, it doesn't make
Well,
sense.
that's why when I was asking, I was like, I don't understand.
There is another one that's like kind of a situation like this, though, that really does happen later in the year, which is what I was thinking of. That's why when I turned and I saw this question, I was like, oh gosh, I probably just really confused them.
I know, I'm looking and I'm like, something is not adding up here.
Literally.
Yeah.
So what kind of graph would you use then for like something like that?
I wouldn't because it's
Oh,
categorical.
you can't graph categorical?
You would have to have done each thing individually, like how many people have each like color hair and done a pie chart or something on that one thing, and then do like eye color on another one. Like when we were choosing like the strawberry vanilla chocolate ice cream
Uh-huh.
thing, like that. They would have to be two separate things. Now we could compare like the number of people with certain like color hair to like eyes based on that, like potentially, but that still doesn't.
Still a stretch.
Yeah.
So is there a way to like correlate those two things then? Like with graphs or no? They're not really
No.
okay.
I mean, in science maybe, and I'm sure there is a way, but
With
not
stats,
anything
no.
that we would do in here.
Okay.
I mean, you could look at the statistical chance that somebody has like blonde hair and blue eyes, I guess, but you'd have to do that as like a combined thing, not like each thing individually. It's not going to work.
So that would be it.
But that's also way more based on genetics than like anything, so it's not going to be like the most accurate information either. All right, last one. Vineyards. Here are some summary statistics for the sizes in acres of Finger Lakes vineyards. Would you describe this distribution as symmetric or skewed?
I just have to like rearrange it.
Skewed?
In
Because,
which way if it's skewed?
Right, maybe?
Why?
Because the median is at like 33 about, and the min is 6, and then the max is like way out at 250.
Yeah. So the mean is greater than the median, so it's skewed right. And I can also tell by the fact that the max is like way out in Nowheresville. Are there any outliers? So I need to check because I'm making an assumption because 250 is so much larger than my median that it probably is an outlier, but I want to know for sure. So Q1, so 18.5. minus 1.5 times the IQR. Q3 minus Q1 is 36.5. And then the other one, the upper one, would be 55 plus 1.5 times 36.5.
First one is negative 36.25.
So obviously I can't have negative acres, so I don't have to worry about it on that end.
And the second one is 109.75.
All right, so based on that, are there any outliers?
Yep.
How many?
Just one, right?
Do I know that for a fact? Do I have a list of numbers? No, so I want to say at least one. Because there could be more.
So it's not graph, that's what you'd always do? Just like at least however many we get.
If they don't give you a list of numbers or like the histogram like we had in the other one, then because I wager there's another number in there somewhere between the 109 and the 250 for the mean to be as drastically different from the median as it is. But I don't know that for a fact because I don't have a list of numbers. So on this one, I'm creating a box plot again. So the way I like to do this is when I put the numbers on here, and this is in, what is it, in acres. So I'm going to put that little word there. But I like to do, you know how people do like 1, 2, skip a few, 99, 100. So I kind of like to do the same thing here. I'm going to go out to like, I'm going to do increments of, well, I guess I'll do increments of like 10 or 20. And then when I get over here to like the 110 range, I'm going to do a little skip a few and then call that 250 because that's my max value, just so I don't have to write in all those numbers because that's just excessive. So 0, 10, 20, 30, 40, I hope I left enough room, 50, 60, 70, 80, 90, I almost did 100. Need to shift this just a little bit. $110, $120, skip a few, go to $250. So the main reason I do this is so that I don't have to, go out ridiculously far, but I can put my outlier at 250. Now my min value is 6, so I put that on. Q1 is 18.5. So then I connect my little whisker. Median is 33.5. Q3 is 55. Then my max is 250, but I know that's an outlier, so I'm not going to put that. I only have a 5-number summary, essentially, so what do you think I should do?
Use the upper fence.
Use the upper fence, so 109.75. And so if you didn't remember that mean being greater than the median meant that it was skewed right, or you didn't infer that from a max of 250 that it was skewed right, most certainly at this point you can tell that it's skewed right, and so you could always go back and answer it. So don't ever feel like, especially on like a quiz or a test or something, if you're like, I really don't remember this, go down and see if any other data will help you, or even if I don't ask you to create a box plot, create one, because that will pretty much tell you what's happening from there. As far as kind of like summarizing it up, We're anywhere from 6 to 250 acres. The bulk of them, most are around, I would say, like 33 to 34 acres. And remember, because it's skewed, I'm looking at the median when I'm saying what they're around. And the middle 50% are between 18.5 and 55. And then I would also say something about one outlier, or one known outlier of 250. Because like I said, I would, if I had to put money on it, I would say there's at least one more outlier in there somewhere, but I don't know that for a fact. But that pretty much wraps this chapter up. Tomorrow we'll look at chapter 6 notes, and then probably after that you'll have a little bit of time left. So if you don't finish these, obviously you're not going to finish them in the next 5 minutes, but I don't think chapter 6 notes are like super, super long. So we'll probably go through those, but we won't start examples most likely until Wednesday. It depends. If they're really short, we may, but I might just give you time to work on these problems a little bit. I don't really remember how many you have, but